In this video, we're going to go over worksheet 6, assignment 1, Newton's laws. We're going to do worksheet 1 and worksheet 2. This one has, okay, so let's preview this. It says 4 questions for 12 points. Most of them have 15 points. In question 1, Newton's first law. Remember, Newton's first law says an object at rest stays at rest. So that is the law of inertia. And an object in motion stays in motion. Stays in motion. Okay, I'm running out of room there. All right, so Newton's first law states that an object at rest stays at rest. So that's the law of inertia. The tendency of an object not to move or to speed up or slow down. An object in motion stays in motion at constant velocity. So we don't see that happening on a regular basis with us because there's a lot of forces that slow things down. And we see this in space all the time. We can give a satellite just a little bit of acceleration in space and it goes on forever till it hits something. Okay, question 2, which is Newton's second law. Remember, Newton's second law says a force is equal to its mass times its acceleration. So the larger the mass, the more acceleration it's going to have. It's going to need a greater force to accelerate it. And the smaller the mass, the acceleration can be small to give it the same force. So basically saying here that a force can cause an acceleration on a mass, and the larger the mass, the greater the force. Okay, what is the force needed to cause a 12 kilogram object to accelerate 4 meters per second? So there's my mass, there's my acceleration. So I use that force is equal to ma, m times a. So 12 times 4 gives me 48 newtons. And remember, newtons is my unit here. Meters per second is a velocity. Question 4. All right, so use the graph below to answer the question. If an object weighed 10 kilograms, what force would be required to cause it to cause acceleration from 0 to 1 second? So the acceleration here is this, 20 meters per second squared in 1 second. So my force is going to be 10 kilograms times 20, or 200 newtons. All right, so we're done with that one. I'll get the next one up. All right, so W6 assignment 2. What is the gravitational force acting on a horse with a mass of 500 newtons? So we're looking for the newtons, and that newton is weight. So we know that force is equal to 500 kilograms times the acceleration due to gravity, 9.8 meters per second. We're going to use a negative number in here because it's directed downward. So that is 4,900 newtons, or negative 4,900 newtons. Newton's third law states that every action an equal and opposite action results. That's true. So we take a look at this in terms of a wall. I push on the wall with 10 newtons. The wall pushes back on me with 10 newtons. If that didn't happen, let's say the wall didn't push back, then I would go through the wall. And if there was more force coming from the wall, it would be pushing me back. So that's that action reaction pairs. The wall is pushing back on me, I'm pushing back on the wall. You push on a table with a force of 5 newtons. What is the reaction force? The table's pushing back on you with 5 newtons up. You push down, it pushes up. So sometimes that's called the supportive force. Number 4, you are pushing a couch. So let's draw this couch. I like to do the couch. So we have a couch, table legs here, boop, some cushions. All right. So you're pushing to the left 5 newtons, and your friend is pushing the same couch 5 newtons to the right. So our net force, they balance each other out. So we have a 0 net force. Net equals 0. So it's not moving, or at least it's not accelerating. So what is acceleration? It is not accelerating, so it's 0 meters per second. Number 5, Newton's first law states that an object at rest stays at rest. An object in motion stays in motion with constant velocity unless acted upon by an unbalanced force. Newton's second law, remember, is that force equals mass times acceleration. Newton's third law, for every action there is an equal and opposite reaction. And we know that the law of gravitation, all objects that have mass attract each other with gravitational force. So the larger the mass, the more gravitational force. So that is it for worksheet 6.